community cohesion and well-being of children worldwide. I request Dr. Aram, please come on to the dais. Thank you very much. I also delighted to introduce our co-chair, Dr. Ashok Dalwai. He is IAS retired. He is currently the chairman of the Indian Institute of Social and Economic Change, Bangalore, and the Karnataka Agriculture Prize Commission, KAPC, Government of Karnataka. A 1984 batch IAS officer with a PhD in economics. He has held key administrative roles across Karnataka, Orissa, as well as Government of India, and played a major role in urban and agriculture reforms. Nationally, he is best known for chairing the Committee on Doubling Farmers' Income, where he advocated diversification into horticulture, animal husbandry, and fisheries, along with better post-harvest management and value chain development, particularly for millets. He promotes a Green Revolution Plus model aimed at increasing farmers' income, nutrition security, and sustainability. He has published more than 80 general interest and technical papers, besides contributing chapters to various edited books. He has been conferred several awards, including 3 honorary DSc, 1 DLit, and professorship by different universities of the country. In 2002, in a survey by Times of India, he was recognized as one of the 10 most important persons of Karnataka. With this, I hand over to Dr. Aram and the co-chair to conduct the proceedings. Thank you very much.
Good morning, everybody. What a wonderful 2 days it has been, celebrating the life, the legacy, and the impact of Professor M.S. Swaminathan. Every speaker on the dais, but every participant in this wonderful hall, 1,200 of us representing not just the world of expertise that is at the service of people, but also the young and budding scientists who came in the hundreds to listen, have an important task ahead. As we celebrate, and as we rightly said, the centenary is not merely a tribute to the monumental achievements that Dr. M.S. Swaminathan achieved in his lifetime, but it's also a call for action, reaffirming our global commitment to sustainable agriculture, food and nutrition, and a hunger-free world, a dream and aspiration that has to make the rounds of every country. For in the midst of plenty, that we still speak of hunger is ironical and unacceptable. Meeting in the capital of our country, remembering Professor M.S. Swaminathan, we should also pause and look back at what it means to be a nation of 1 billion people. A nation where we can count proudly that innumerable children and young people make up more than half of our population. Here, when we work for food security, or we work for global health, or we work for poverty alleviation, the impact not only is felt across the wonderful landscape of our dear country, but the impact is worldwide. As I often say, 1 out of every 5 children in the world is an Indian child. 1 out of every 4 young person in the world today is an Indian. So what we do here will shape India, but will shape the world. And in this we find Professor M.S. Swaminathan's vision of cooperation among individuals. We also know his call always for institutions to come together. And I thank Dr. Soumya Swaminathan for her leadership in bringing some of the best institutions of the world to reflect on what can be done. The challenges that we address in this wonderful celebration are complex and reflect the current state of the global food insecurity, but also it calls us to charter a course for a sustainable and equitable future. Mahatma Gandhi said very poignantly, what we do today will determine our tomorrow. In those simple words, we find purpose. In those simple words, we find a continuation of inspiration, that our work, our expertise, our commitment to everyone, especially the most vulnerable, Sarva Udaya, as Mahatma Gandhi articulated, has relevance in this world that is looking for more peace, more equity, and a more prosperous future for all. We have an amazing lineup, and I have an amazing co-chair here. I will invite him to say a few words so that we can give the speakers of the morning enough time to elaborate their thought. May I, with deep pleasure and honor, welcome my co-chair, Dr. Ashok Dalwai, whose CV is impressive. We all have had a chance to read it, but we are eager to hear your words in person. Dr. Dalwai.
Namaskar to everyone here. We are extremely grateful to MS Swaminathan Research Foundation, led by the legend's illustrious daughter, Dr. Soumya Swaminathan, for gathering all of us from different parts of the world. As Dr. Swaminathan said, if agriculture does not go right, nothing else has a chance to go right. And we can't agree more with this statement. As a student of economics, I can recall the first principle of one of the well-known economists in the 18th century, Franco Penne, who said among all the sectors of the economy, if there is one sector where output is more than input, it is agriculture. That is the potential that nature has given us. All other sectors of the economy, be it secondary or tertiary, output is equal to input. And this potential of generating multiple times the input we provide through agriculture has been compromised. So the theme over these 3 days of rendering the sector as a tool of biohappiness would be dependent on shifting from fossil resources to bioresources. It is bioresources that will lay the foundation of the bioeconomy, and bioeconomy would be the anchor of a sustainable civilization. So friends, as we celebrate the 100th birthday of Dr. Swaminathan, we are not here just talking about agriculture. We are here talking about the human civilization, and not just human civilization, but the entire life, both organic and inorganic, on this mother planet, Earth. So I would not take any of your time. I'm here to just introduce myself, and thanks to the chair, we will have illustrious speakers who will be sharing their insights into the concept of biohappiness, and all of us together would be able to draw up a Delhi agenda and share it with the world for a new today and tomorrow. So thank you very much. And we will now be welcoming our other colleagues here who will be sharing their thoughts with us. So thank you, and let's give a big clap and welcome the speakers. Namaskar.
Our first speaker is Dr. Dennis Garrity, the chair of the board, Global Evergreening Alliance. He joins us online from Kenya. Thank you for joining us, Dr. Garrity, from there. We know you're a systems agronomist and a global leader in sustainable agriculture and land restoration. Dr. Dennis Garrity chairs the Global Evergreening Alliance, a coalition of 105 organizations implementing large-scale restoration programs across the developing world. He leads the global campaign to evergreen the earth, aiming to restore degraded lands and removing 20 billion tons of carbon dioxide annually. I know this is a goal you've set for yourself by 2050. Dr. Garrity, we know your Healthy Planet Action Coalition also is committed to creating and bringing together scientists and influencers. The intersection of health with environment and agriculture is one that the world is thinking about deeply. So we are eager to hear you. Dr. Garrity, here's your time. We're hoping to hear for about 20-25 minutes your thought on this very important occasion where we celebrate the centenary of Professor M.S. Swaminathan. Over to you.
Thank you very, very much for this introduction. My remarks are on video, and I think the video will be starting in a moment.
Yes, indeed. Thanks to technology, I think we have all these ways of joining in and listening to you. Dr. Garrity, you'll be pleased to know that many young scientists and over 300 students and over 300 farmers from across India have been with us during this 3-day celebration. So quite a rare convening.
That's wonderful. I so much wish that I was able to join you today. I will be actually coming to India very shortly, and that was the reason that I wasn't able to make the second trip so close to the first. But I will be coming to Delhi very shortly for meetings with some of the union ministers, actually. Looking forward to that.
And we look forward to your video presentation now. And if you will stand in later, if there are any questions, we'll open up from the floor. We'll open up for the video now. Thank you.
Good morning. My name is Dennis Garrity, board chair of the Healthy Planet Action Coalition. I really regret not being able to join you today at this centenary conference in honor of the work of Dr. M.S. Swaminathan, for I'm missing a golden opportunity to rekindle my friendships with so many wonderful colleagues whom I've known for decades. But alas, it wasn't possible to travel to Chennai at this moment. I first met Dr. Swaminathan in 1972 on the campus of the Punjab Agricultural University. He was making a visit to the wheat breeding nurseries. I was in awe. A wet behind the ears youngster there at PAU, spending a year as an undergraduate student in agronomy. Meeting the great man as a 19-year-old was a life-changing experience, for his contributions to make the Green Revolution happen were already very well known. My journey from Ohio to the Punjab began during my 11th grade in high school. I happened to read the famous book, Famine, 1975, by two agronomists, William and Paul Paddock. It described the Asian food crisis in graphic detail, and I committed myself right there and then to a career in agricultural development. The Green Revolution was a moment of great crisis when innovative science and practical technology in wheat and rice production came to the rescue of an entire continent. Dr. Swaminathan was a research leader in the midst of this battle. He and his colleagues were wildly successful in increasing food production just when it was sorely needed by millions of people. But he was criticized by some for certain secondary effects of this great humanitarian advance. He recognized the deficiencies, and he was soon championing an evergreen revolution to ameliorate these drawbacks. During the 1980s, when MSS was developing his ideas about an evergreen revolution, while he was serving as Director General of the International Rice Research Institute, I was proud to be working under his guidance to develop more productive and sustainable farming systems in Asia. I picked up on his concept by proposing and working for an evergreen agriculture that could be the foundation for many of the regenerative practices that we'll be discussing in this session. I was deeply grateful that he soundly supported my efforts on this work over the years at Erie and later when I was leading the World Agroforestry Center, an institution where he had served as the founding chairman of the board. Well, today we face another great human crisis, a crisis that massively threatens the future of food production and food security, not only in India and Asia in general, but throughout the world. I'm referring to the great global heating emergency. And my question is this another green revolution moment? The most recent science tells us that there has been a dramatic acceleration in global heating during the past decade. We are now seeing temperatures rising at the incredible pace of nearly half degree per decade. This has upended all of our expectations of how much time we have left to grasp the nettle and stop global heating before it's too late. We're all aware that we've now surpassed 1.5 degrees of global heating during the past couple of years. This has blown a big hole in the entire Paris Accord target, and it has come decades before it was expected. This has happened faster than the models projected because the Earth's energy imbalance has been rapidly deteriorating. The energy imbalance is the difference between the radiation absorbed by the planet and the radiation that is re-radiated back into space. The Earth is getting darker, and it is reflecting less and less radiation. The planet is now absorbing massive amounts of heat every year because its albedo has declined by 2.5% during the past 20 years. This is caused by several feedbacks. First and foremost, the planetary cloud cover has been markedly declining. This reduces sunlight reflection. Second, human aerosol pollution has been declining. This also reduces sunlight reflection. Third, the ice sheets at the poles are disappearing, causing the oceans to absorb more heat. And in addition, the capacity of the terrestrial environment to absorb carbon is also declining. The land is storing less and less carbon. These are the sources of the great global heating acceleration. Thus, the most recent projections show that the planet is now expected to heat up to over 2 degrees by the late 2030s, just about a decade from now. That's a sobering thought. And when we blast past this deep red temperature line, we'll be posed to barrel right on to exceed 2.5 degrees by about 2048, and then surpass the absolutely catastrophic level of 3 degrees by 2060. Now, are these projections plausible? Actually, they're conservative. Why? Because global heating is no longer controlled simply by the emissions of greenhouse gases in the atmosphere. The recent doubling of the rate of temperature rise is now mainly caused by these reinforcing feedbacks and tipping points. They are activating in response to the elevated levels of temperature that we've already reached. We know that 9 of these tipping points have a greater than 50% chance of being triggered by the time we reach 2 degrees. And all of these feedbacks, and others as well, are quite likely to cause a further acceleration of global heating beyond what we see in this table. The bottom line is that, at this point, greenhouse gas emissions are still increasing, and no amount of emissions reduction is going to have any significant effect on reducing the rate of temperature rise within the time frame necessary to avert these temperature cross points. Likewise, no conceivable ramping up of greenhouse gas removals can have any significant effect on the great global heating acceleration either. Removals are crucial, but gigaton levels of removals are decades away. We face a very stark situation. There is only one tool left in our toolbox that can halt the incessant rise of temperatures within a decade or two. That is direct climate cooling methods or climate interventions based on enhancing sunlight reflection. That tool can buy us time to save us from further feedbacks and tipping points that could drive the planet right into a hothouse Earth scenario. Such a hothouse Earth may drive temperatures to well above 4 or 5 degrees before the end of this century. That is foreseeable now, and that is dangerous beyond measure. Humanity must come together immediately and develop and deploy an emergency plan to integrate all of our tools and deploy that plan to halt global heating by 2040. And then to begin to bring temperatures back down to a safe level of less than 1 degree before it's too late. How would Dr. Swaminathan regard our approach to this crisis? No doubt he would have us face it head on with a deep confidence and abiding faith that once again, science and technology can help deliver us from the worst of it. I believe that he would see the great global heating acceleration emergency as another green revolution moment. He would see the small number of heroic scientists who are working on a range of promising sunlight reflection methods as key to humanity's future. And he would encourage them to willingly face the wrath of the misguided in the same way that he had to face criticism for his highly innovative methods to achieve the first green revolution. Just like during the early stages of the Green Revolution, when there were just a few scientists working in obscurity in their wheat and rice breeding plots, today we have similarly a very small but growing number of scientists and engineers working to develop life-saving methods of reflecting more sunlight back into space. They face quite rabid criticism for what they're doing, but they know, just like the pioneers of the Green Revolution, that innovations always face opposition due to unfounded ignorance. We are fortunate that they have the inner motivation to carry on, because as the massive acceleration of global heating begins to bite ever harder and the weather disasters begin to mount up dreadfully, including severe droughts imperiling the regional and global food supply, humanity will turn to these scientists for delivery. What solutions are they delivering? Well, they're currently working on more than 15 direct climate cooling technologies. The two most prominent and feasible of these are shown in this figure. The most practical is lofting a thin veil of reflective particles up to high altitudes above the Earth. We know this works effectively, and that it is inexpensive and relatively safe. It mimics volcanic eruptions, like Mount Pinatubo in the Philippines, that lowered the temperature of the entire planet by 0.5 degree for 2 years during the 1990s, with no discernible negative effects. And then there is marine cloud brightening that lofts sea salt particles into the clouds to reflect more sunlight back into space and help replenish the planet's cooling cloud cover. Both of these technologies are relatively mature now, and they can be deployed very soon. But there is a great gnashing of teeth these days about these solutions. Many are saying, hands off, Mother Earth. And yet, we've actually been choking Mother Earth now for many decades. Our only salvation is to use caring hands to become much better stewards of her future. We must first slow down the acceleration of temperatures and then halt the temperature rise completely before it reaches 2 degrees in the late 2030s. And then we must guide global temperatures back down to safe levels as soon as possible after that to avert a massive number of tipping points from being triggered. Ultimately, the deployment of these technologies is inevitable once humanity wakes up fully to the dire fix that we are in. We can only hope that we have the good sense today, as we did in the past, to follow the science, to mobilize it, and to put it to work to help solve the mother of all global crises, the emerging burst of accelerated global heating. And if we fail, well, we already have ample evidence that billions of vulnerable people, particularly in the global south, will endure levels of suffering that we can hardly imagine at this juncture. The severity of the excessive heat events, droughts, floods, storm surges, sea level rise, and ecosystems collapse that we are seeing all around the world already will intensify. Not linearly, but exponentially, as temperatures climb from 1.5 degrees to 2, and then to 2.5, and then to 3 degrees during the next 25 years. India has already experienced the suffering of hundreds of millions as excessive heat makes life nearly unbearable for many vulnerable people, particularly the poor and farmers in rural areas. But we have not yet experienced the widespread food production deficits that are inevitable as temperatures rise to these unimagined levels. We in the agricultural scientists must be on the front lines, raising the alarm about the food production risks that humanity will be facing if we don't act immediately to avert the crisis. For there is strong and consistent published evidence that we could dramatically reduce these risks by deploying sunlight reflection methods to cool the planet. We have technologies that would dramatically reduce the risks of excessive heat events, droughts, floods, storm surges, sea level rise, and ecosystems collapse. It has been said that doing this will be a victory, not just for ourselves. It will be a victory for all humanity and future generations, so that we can anticipate better days to come. Do contact me if you wish to learn more about this topic, and thank you for listening.
Thank you very much. Yeah, thank you very much. I think all of you will agree with me that we have listened to one of the most insightful, forward-looking talk by Dr. Dennis, a respected student of Dr. Swaminathan. The talk was full of content based on science, and there's also simultaneously a poignant call to the humanity to make a change. We certainly are at an inflection point in the history of civilizational agriculture and human civilization. So after listening to Dr. Dennis, we move on to the next speaker of the day, Dr. Arunabh Ghosh, Chief Executive Officer, Council on Energy, Environment and Water, New Delhi, to share briefly about this illustrious speaker. Dr. Arunabh is a globally respected public policy expert, author, and institution builder. As founder CEO of the Council on Energy, Environment and Water, he has led it to become one of Asia's top think tanks and a global leader on climate policy. He helped shape the International Solar Alliance and co-founded the Clean Energy Access Network. With over 20 years of experience, Dr. Arunabh advises governments and global bodies. In 2024-25, he was appointed to India's Air Quality Commission and named Special Envoy for Brazil for COP30. He co-chairs the World Economic Forum's Global Future Council on the Energy Nexus. He is also a Vice Chair of the United Nations Committee for Development Policy 2023 to 2025. So we will now listen to continued dimensions of climate change and impact on agriculture. Dr. Arunabh, the floor is yours.
Yeah. Thank you. Good morning, Dr. Soumya Swaminathan, Dr. Aram, Dr. Dalwai. My sincere gratitude to the MS Swaminathan Research Foundation, the National Academy of Agricultural Sciences, the Indian Council of Agricultural Research, and Government of India's Ministry of Agriculture and Farmers' Welfare. It is a sincere honor for me to deliver a lecture at this birth centenary conference of Professor M.S. Swaminathan. Unlike the previous speaker, Dr. Dennis Garrity, I did not have the privilege of meeting or working with Dr. M.S. Swaminathan, but of course, it goes without saying that we are all deeply inspired by the work of Professor Swaminathan, and even more importantly, the legacy of institutions he has left behind. And it is a privilege to be partnering with some of these institutions to take forward the work in the face of new types of challenges. While I will deliver a lecture on how a changing climate and the stresses on our water cycle will then impact some of the other systemic imperatives that we have, I can't help but also briefly comment on what Dr. Dennis Garrity just presented. I think it's a very important subject that he touched upon, and the toolkit that he was referring to, whether it is emissions reduction, carbon removal, or at least temporary interventions at a planetary scale to reflect more sunlight, increase the albedo, basically, of the Earth's surface, to reduce the amount of ultraviolet radiation that's reaching the Earth's surface. It's something to be explored. However, the only thing I would say at this point on this issue is that this is not just a science and technology issue, it is also very much a governance issue. I have personally worked on the governance of solar geoengineering for 15 years, having co-chaired the Royal Society's International Governance Working Group on Solar Radiation Management, and currently I sit on the Oversight Committee of the UK's Advanced Research and Invention Agency on exploring climate cooling program. And these are very much technologies that are as Dr. Garrity outlined, being experimented with by a small handful of scientists spread across the globe. But the science and the governance must go together. If there is any lesson that we learn from the Green Revolution, it's not just that science and technology were available to us, but that we built institutions and we built ways of cooperating across countries, building networks of scientists and research foundations and social scientists and farmers. We have to think about similar governance structures when we think of planetary scale interventions. If climate change is an outcome of unhindered planetary scale intervention from our side as humanity, then I would argue that any interventions to counteract climate change should not repeat the same mistakes. That being said, let me turn to the subject of my presentation. And I've titled it Water that Flows Through Nature, Economy and Governance. I'll draw upon some of the work that we did as part of the Global Commission on the Economics of Water, of which I was a member from 2022 until end of 2024. This is a commission that was led by President Tharman Shanmugaratnam of Singapore, Dr. Ngozi Okonjo-Iweala, the Director General of the WTO, Professor Johan Rockström, and Professor Mariana Mazzucato, and I was one of the commissioners. The Global Commission on the Economics of Water published its interim report during the UN Water Summit in 2023 and its final report in 2024. But I will also be drawing on research that we are doing at CEW, my institution, along with collaborators elsewhere, on how do we think about these global water challenges and what does that mean for India, not just for agriculture, but the broader aspects of water flowing through our economy. As a brief introduction, the Council on Energy, Environment and Water, which I lead, is an independent research institution aiming to impact sustainable development at scale with data, integrated analysis, and strategic outreach. Our work spreads across a range of subjects from low-carbon pathways modeling to energy transitions to the air we breathe, the water we drink, the food we eat, but also the enablers of science and technology and finance and circularity and resilience. Let me start with a little bit of an exposition on the hydrological cycle. I hope you can see the graphic, the schematic graphic well. The idea here, and many of you, or perhaps all of you, are fairly familiar with the hydrological cycle overall. But the point I wanted to make here is actually the vertical, the precipitation that you see over land. And we notice that unlike popular public perception, the bulk of precipitation that falls over land is actually not blue, but green. It's what is called green water. And that is what then goes into our soil, the soil moisture, into our plants, and then evapotranspires back into the atmosphere. Equally, the amount of precipitation that's falling over the oceans is, of course, much larger. The ocean to land atmospheric water transport is 46,000 cubic kilometers annually. Why I mention this is that what happens on land, and therefore through that evapotranspiration, the moisture that's going back into the atmosphere and then transferring over our oceans, then impacts what happens in land elsewhere. So focusing on not just the blue water that is visible to us through the naked eye, the water in our streams and our lakes, but the green water that is in the soils, in our plants, has to be a very critical component of how we start understanding the water cycle and also the stresses. This is another map that the Global Commission on the Economics of Water published, which talks about it and builds on that schematic diagram I showed you, on the transboundary water flows. And what you see, the orange parts are really the green water evapotranspiring and then falling as in the blue part as precipitation over land. What you notice is that the land-to-land moisture connections can be seen across oceans, connecting evaporation, for instance, in West Africa to rainfall in South America. Let's take Brazil, where the climate negotiations will be held this year. It receives moisture from across the Atlantic Ocean, but then the green water that then gets absorbed within the Amazon rainforest itself becomes a source of new water that then evapotranspires and falls again as precipitation in other parts of South America. So the Amazon rainforest in this way creates about 36% of its own rainfall. The point I'm trying to make here is that the green water supplies are far more regionally interdependent than we have thus far realized. And atmospheric moisture flows will connect all continents, making fresh water a global common good that needs to be, therefore, governed as such. We notice this also in the form of what we could call net export and net import of water. This graphic shows you how, therefore, different countries are either absorbing water from other regions or sending out water. The point here is not to make it political. The point is to understand the hydrological interdependency that we have across our political boundaries. And that should then impact how we think about trade, about the water that is embedded in our food, in our clothing, in our products. Unless we start factoring in the global water cycle as part of a global common good, we will be suboptimally utilizing the resources that we have and not be able to respond to the crisis of climate change with the warming that Dr. Garrity was referring to. Let me therefore now come to some of the grave points that we highlighted in the Commission's report. We expect that if rainfall that originates from deforestation hotspots were to disappear across the world, you would have about 0.5% to 0.7% decline in the growth rate, the economic growth rate in Africa and South America. Globally, intensely irrigated regions seeing declines in water storage, with some experiencing more than 2x faster decline than historical records. You would see over a fifth, more than 20% decline in global cereal production. Hence, in a different way, a need for a new green revolution. Global GDP losses could be as high as 15% by 2050. As you can see, and as with many of these planetary stresses, the lower income countries will end up having higher losses than the higher income countries. And of course, this then has implications for inequality, with worsening challenges for the poorest 10% of global population. Some work that we had done for India at CW also indicates that upwards of $2.5 trillion in 2020 prices could be the loss just from agricultural losses by 2050. So what do we do about this? The Global Commission on the Economics of Water outlined 5 missions that it felt were needed to respond to this crisis of a warming climate, but also recognizing the hydrological interdependency across our geographies. A new revolution in food systems, a need to restore natural habitats and protect green water, a need to push for a circular economy in water, to ensure that the new push towards AI and a more digital economy is also more water conscious and water efficient, and of course, to try and not leave any child behind when it comes to access to water. I'm going to talk about each of these missions briefly, but I'm going to also pair them with some of the work that we've been doing in India and what it means. Mission 1, launching a revolution in food systems. The challenge, we all know, much of water used is for agriculture globally. There'll be a 60% rise in food demand across the world. Nearly half of India's population is dependent on agriculture. We get about 15% of our GDP. So what are the goals that the Global Commission put out? A goal to have at least 33% reduction in water use through improved irrigation techniques and climate-resilient seed varieties. At least 50% of global cropland to move towards regenerative agricultural systems, scaling up organic carbon storage in soil and soil water retention, and 30% protein intake to be plant-based by 2050. Now, if I think about India, I'm sure, unfortunately, I could not attend the sessions on the first and the second day of this conference, but I'm sure some of these themes have been touched upon. One piece of work that we did at CW was mapping out sustainable agricultural practices and systems of agriculture across the country. We looked at more than 30 such practices and systems. And we found only 5 of them, which are listed there, that crossed 5 million hectares out of our about 140 million hectares under cropland. Those are agroforestry, precision farming, integrated pest management, crop rotation, and rainwater harvesting. How do we not only take these to a much larger scale, from 25 million hectares, say, for agroforestry to much higher, but also for all those traditional agricultural practices that we do have, but which are currently at sub 5 million hectares. So this is both the challenge and the opportunity. And when we look at what are the factors that results in a scale of these kinds of more efficient technologies, we see that institutionalization at the community level is at the heart of the story. Of course, government intervention is needed. This is the story of India's Green Revolution, sustained leadership. And I'll talk about financing later, but the community ownership of these practices will be absolutely critical. I don't know if there's been a discussion of millets. I'm assuming there has been, but the Odisha Millet Mission is an example, and now there are several other state governments that have introduced millet missions. But this is something that we can draw on as the reintroduction of millets as a drought-resistant crop, bringing millets into government-run schools, into bringing in the community, but linking it to the district and state level departments, and then making it into a statewide mission. So can we start doing this for crops that are more water efficient, more climate resilient, more nutritious, but do it at scale? Mission number 2, and this is where again the green and blue water story comes together, and that is why I say water flows through nature and the economy. The challenge is that there's been severe ecosystem decline and deforestation globally and loss of natural habitats. And as a result, that surface runoff has increased, the water retention, that 60% of green water is that we should be tapping into, we are suboptimally utilizing. So the goals here are restoring degraded ecosystems, conservation of forest ecosystems, protection of inland water ecosystems. But some of the evidence suggests that the benefits can be 10 times the same. So what do we do? At least for India, we all recognize that 2/3 of our agricultural land is rain-fed. That means the importance of green water and soil water retention, it becomes doubly more important. Agricultural productivity is lower when green water is limited. But soil conservation practices, similar to those I highlighted in the previous slide, with mulching, contour farming, terracing, cover cropping, etc., can improve that water holding capacity. and savings can range from 20 to 60%. Now, please don't cite this. This is work under progress, therefore not to be cited yet. But we just looked at, I'm just bringing this to your attention because of some modeling we've been doing in one of the river basins in India to just demonstrate the impact here. Now, what am I trying to show here? The graphic shows the impact of tree cover and precipitation changes on the hydrological variables. The left-hand side panel shows how the precipitation change in soil moisture, which is indicated as blue, groundwater is green, and runoff as red, in response to the changes in, and the right-hand side is related to changes in precipitation. Now, changes in rainfall tend to push both runoff and groundwater in the same direction. So if there is more rain, like today, we'd see both quicker surface runoff, but we'd also see more potential recharge. When rainfall increases, please look at the right-hand side panel and the right of the right-hand side panel. So when there's a 30% increase in precipitation, you're also seeing both surface runoff and water retention in the groundwater increasing, and the flip side on the other side of this same panel. However, now turn your focus on the panel on the left, which is about tree cover. Now, this is where it gets interesting because vegetation modifies this story between how much is retained within the soil, how much goes off as groundwater, as surface runoff, but also how much gets absorbed in the trees itself. Tree cover changes alter how a given precipitation pulse, whether say increase or decrease, is split between evapotranspiration, soil infiltration, surface flow. Severe tree loss, as we see across many parts of the world and in India, will then have a challenge in terms of how much water is able to be retained within the soil and increases the surface runoff. At the same time, moderate afforestation can both increase recharge while improving soil infiltration. The point I'm trying to make here is that blind deforestation obviously is a problem, but blind afforestation can also be a problem if we don't think about the natural ecosystems and the type of species that are planted, which then balance out how much the plants absorb, how much the soil absorbs, and how much goes as surface runoff. This will be critical to bring in the green water dimension into our overall hydrological water planning in order to respond to the crisis that we are faced with. The third mission is about circular economy. Across the world, water leakage results in nearly $40 billion in losses to the global economy. And of course, there is a huge amount of carbon emissions that result from treating the lost water. The idea here is that can we reduce non-revenue water by 50%, recycle 50% of wastewater, and recover resources from that wastewater. Right now, only 11% of global wastewater is being reused globally. Again, please do not cite these numbers. This is work underway at CEW, so I'm just presenting some preliminary results. This has not been peer-reviewed yet. We estimate that about 1,500 billion cubic meters will be the water demand, which is more than the utilizable water that we have in India, which means that we have to start thinking seriously about reusing each drop of water multiple times over, not just in agriculture, but in all the growing sectors of the economy. Our conservative estimate is that this is a huge economic opportunity as well. Between $27 to $36 billion of economic opportunity by 2047 from the recycling and reuse of wastewater in the country. This is both the value of that water being reused, but also the investment opportunity that you have in investing in these technologies, and also a huge employment opportunity. Now, this is published work that we did in about 500 odd cities across the country, and we used multiple variables to look at are our urban local bodies getting ready to tap into this opportunity. And what does getting ready mean? Do they have a policy framework in place? Do they have some financial allocations in place, etc., to do this? And very few are right now in a category. I know, I'll wrap up very soon. Very few are in the category of leading or outstanding in terms of being ready for treated water reuse, but it also demonstrates the opportunity. I'm going to now wrap up in the next 2 minutes. The fourth mission was around having a water-efficient approach towards clean energy and AI. You can see that there will be a 2x increase in electricity demand alone because of increasing demand from the digital revolution. And each kilowatt hour of energy that is used in a data center, for instance, needs 2 liters of water. So we need much more water-efficient technologies to drive this energy revolution. And this research shows you that, again, it's some of the clean energy sources, solar or wind, that have some of the lowest water footprint. So if you want more energy to drive the AI revolution, it also means that that energy ought to come from more water-efficient energy technologies, which also happen to be clean energy technologies. Finally, let me come to the issue of leaving no child behind. We still have, I think Dr. Aram was also referring, 2 billion people without access to safe water in the world. We have to focus on more decentralized water systems, more energy-efficient desalination, closing the water storage gap. Again, the climate crisis makes the problem more difficult for us. This is work that CW did with UNICEF last year, the first district-level risk index on the impact of climate change on WASH services, water, sanitation, hygiene. And we find that 40% of India's districts are under very high and high risk. So again, we have to start building resilience, and to do that, we have to start by building up the data sources that can inform policy. I'm going to end with just 2 themes, one on finance and one on data, therefore. We talk about financing, whether it's about climate, whether it's about energy, and now it's about water. There's about a nearly $476 billion financing gap that comes in the water sector alone to meet SDG 6. And yet across the world, counterproductive subsidies in agriculture or poorly defined subsidies in water and sanitation are upwards of $700 billion. So how do we repurpose the subsidies for the poor and the vulnerable and to deal with these crises? The last one, maybe it's hard to read this, is actually about data. Water data is missing in our country, in our cities, in our states, globally for many reasons. There are technological reasons, financial reasons, legal reasons, political reasons. This is some work that CW had done for the Global Commission. We need to start thinking about data much more seriously if we've got to confront these compounding crises. We need to start by valuing water as a natural capital. That's why I say water flows through nature, the economy, and therefore this governance of data, of finance, and of water overall. Then we need more consistent regulatory standards for water disclosures from our companies, from our agriculture, from our consumption. That can then help to create and strengthen the capacities for better water data collection, but also then use that to drive finance towards improving the data infrastructure and building a much more robust global water data infrastructure. I have tried to give you an overview of the emerging science at a global level, the missions that we've articulated at a global level, but also work that we're doing at CW along with our partners, what it means for India at a national and a subnational level. There's a lot to do, so let's bring our hands together and work together. Thank you again for your attention.
Thank you, Dr. Ghosh. Not only is data missing on water. I think beyond the headlines, we have not taken enough time to look at the interdependency of water and every other battle that we are fighting. We had two wonderful talks. I think one that looked at the cost, the social cost, the economic cost, the cost in the lives of people when climate change is triggering higher temperatures. We also heard about hydrological interdependency and how it can affect all of us. In both the presentation, you heard very clearly the cost of inaction. You also saw, I think, the inspiration that we continue to draw from Professor M.S. Swaminathan's example of expertise being in deep conversation with institutions that influence governance, but also, I think, architectures that influence the lives of all people, particularly the most vulnerable. The cost is pronounced when it comes to the poorest amongst us. And as someone who works for children, I know that cost is even more accentuated when it comes to children. And this is something that is also missing from our lens of analysis. When Dr. Ghosh was saying water flows through nature and through economy, I wanted to just add it flows through the lives of our children. And it's their lives that we put on the front lines. We've had two excellent presentations, materials that will be available, but let me open the floor for 3 questions, and then we will ask both our panelists to respond to it. So the first question right here. Please go ahead.
Dr. Dennis and Arunabh Ghoshji, thank you so much for the presentation, highlighting the urgent needs for reassessing what we know and what we communicate to our public. I see there's a gross misrepresentation of information in the public, and it emphasizes much more needed efforts into scientific communication. The contents that our public, our schools, our children, our teenagers, and our youth is consuming does not do them good, because they really don't know the urgency of the situation, like Dr. Dennis highlighted. And therefore, I really felt the need of institutionalization highlighted by you is much more urgent. What efforts or what measures can we do to make it happen so that our public develops scientific aptitude right at the core level, and these meetings don't remain closed to just the language of specific experts?
So we get the question, it's how people can participate and how can institutions be more engaged. We'll hold that. I will come to the next side so that we are representative. Please go ahead, sir, on the 3rd row.
Thank you. My name is Carlo Fadda from the Alliance of Biodiversity and SEAT. The question for Dennis. Dennis, really nice to see you. My question is twofold. On the one hand, I really appreciated your excellent presentation, but maybe if you can elaborate a little bit more on what could be the negative effect or the unforeseen impact of the methodologies that you were proposing. Similarly to the Green Revolution, obviously those who were addressing the famine didn't think enough about the side effects. And the other is about the general public, because as you know, I mean, it's very difficult to distinguish the truth from the fake at this moment. No? When you do a Google search, you find a theory and it's opposite. So how can we really, I mean, how can this be mainstream? And even in some very important governments, there is a lot of denialism of the importance of science. So how can we try to be really convincing the people?
Another question on the people's front and another question on the side effects. Please keep your questions short so that we devote the time for the answers. Please go ahead, sir.
Thank you so much. Dr. Ghosh, you mentioned about circular water economy, but that circular water economy also requires multidimensional transformation of existing economic systems, including private and the public. My query is, what kind of creative transformation and links should happen between circular water economy and solidarity economy via, for example, the cooperatives and self-help groups being given charge? And very quickly, Dr. Garrity, what are the side effects of these technologies, and in what way, not only the governance issue, but what kind of people's initiatives must be so that it is not just considered only as a technological solution?
I will have to stop here so that our panelists get a chance to respond back. May I ask Dr. Garrity to come in first, and then Dr. Garrity, please go ahead. You heard the questions.
Yes. Thank you very, very much. Wonderful questions, and I wish I had had more time to talk about some of those issues. But I believe that the questions that were directed to me really focused on two things. One was, how do we communicate the science and the knowledge to the vast numbers of people who need to know to be able to influence their behavior and their institutions' behavior and governments? That's number one. And number two, I think Carlo and the third question also dealt with what are the side effects of these technologies that we need to be aware of and what might be their implications. So let me take communications first very briefly. We have no doubt a tremendous challenge. The data that I presented to you is very recent data on the projections of global heating and its acceleration. And only a very, very small number of people around the world have any idea of how dire these dates of cross points for 2 degrees, 2.5 degrees actually are. It will take some years, I believe, before that communications can be fully exploited to present the science to the general public, because even the science community is only waking up to this currently over the past few months. So I have no ready answer to that, but I do know that, or I do believe that the key to the taking action on a comprehensive new climate restoration plan is really the aegis of heads of state and senior officials in governments. And I have a great hope that the climate vulnerable countries, the most climate vulnerable countries, those that are clearly going to be experiencing the brunt of these climatic disasters of droughts and storms and hurricanes, cyclones, food deficits. We know already what to expect in terms of the levels and intensities of these that we will be seeing at 2 degrees or 2.5 degrees. And so then we need to compare them with the risks that we would see with the application of technologies like those that I described for sunlight reflection. And so the communications is going to be an enormous challenge. The second issue was side effects. And there are a number of side effects that have been identified with these technologies. Let us recall that every technology that enters human experience has some side effects, some deficiencies that need to be accounted for. But I have reviewed the literature. I have many, many colleagues who have done research on these side effects. And actually, what has been determined is that the risks that are known for deployment of these technologies are really infinitesimally smaller than the risks and side effects of not deploying these technologies and allowing temperatures to advance to 2.5, 3 degrees. So we're talking orders of magnitude difference in the risk comparison between the side effects on both sides. I could, some of the side effects we're talking about are effects on the ozone layer, differential effects on regional precipitation, and a number of others. But the ozone side effect has now been studied, and it is really quite small, fortunately. And regional precipitation deficiencies, and there's a lot of discussion about how the lack of these technologies or the use of these technologies would affect the monsoons. And what we are finding is that the way that you apply the technologies is the crucial thing for avoiding the discrepancies in precipitation. And the most recent work on this has shown that actually, in addition to a general global uniform reduction in temperature, we can expect a fairly general uniform reduction in precipitation if and when the technologies are applied according to the latest understanding of the work that has been done. So I think I'll leave it at that, and there's much more to be said.
Dr. Garrity, I know we could devote a lot more time, but I think you've scratched the surface and pointed to some areas of work. Dr. Ghosh, so much of thought triggered by you. Will you respond to the two queries, but also your concluding thoughts?
Sure. Thank you. I'll keep it brief and happy to discuss more offline. On the first question, ma'am, about scientific aptitude and the need to institutionalize, I'll just give two suggestions. One is when we think about climate risks, I think the more we distill the hyper-local nature of the risk, the more we come closer to communities, people, students, etc., to help them understand. Assuming that everyone is going to read through all the journals on climate science is, might be desirable, but it might not be practical. But works, for instance, that we've been doing in, say, the city of Thane in Maharashtra, we've developed heat and humidity risk assessments at a neighborhood by neighborhood level. So if you're a construction worker in one neighborhood and your office goer in another neighborhood, you have an idea of not just the exposure to the heat stress and the humidity stress, the wet bulb temperature, but also what kind of public health facilities might be there in that neighborhood, what kind of administrative capacity might be there to respond. That's what makes these issues much more real. The same, another example is really about data, the point I concluded my lecture on, that we really have to make data a lot more accessible. So one of the things we try to do at CW is make our data sets public. Sometimes the data exists, but it exists in institutions, and nothing wrong with that. But then institutions become inaccessible, whether it's government institutions or non-government institutions. So we have to figure out the data protocols that we can make the data available much more readily for other researchers to draw on. And on, sir, your point about circular economy, it's an incredibly thoughtful question. I don't want to shortchange it by a quick answer, but I do want to highlight two examples, not as kind of generalized responses, but to your point about circular and solidarity economy. When we think about regenerative agriculture, where is regenerative agriculture actually being practiced? It's by the smallholder farmer, often the smallholder woman farmer. Work that I have personally witnessed in Andhra, work that my colleagues have been doing with communities. It's the farmer who is also not only practicing new forms of regenerative agriculture, but also at a different time of day, selling some of say the natural farming ingredients, etc., through their shops, through their women-run self-help groups, trying to understand how as the community they can support each other through a transition from one type of agricultural practice to another. The same we see in decentralized water treatment. We have 4,500 cities. We're not going to have giant sewage treatment plants everywhere. Decentralized water treatment for circular economy is also something that is much more conducive to working with community organizations than the top-down, capex-heavy models that we've witnessed so far. Have we done it at scale? Certainly not. If I could take just 15 more seconds, again to the point I think Mr. Carlos raised, there are a range of potential negative impacts. The research is continuing, but I would again urge that a lot more cooperative, collaborative work is needed across scientists, especially in the developing world. The science right now, the research right now is too general and planetary in scale rather than what will happen to precipitation in Kenya, what will happen to precipitation in South Asia, etc. So again, working on this is not just a scientific endeavor, it is very much required to deal with the imperatives of climate cooling technologies if we have to have an equity and climate justice lens applied to it.
Great. I think that urge, Dr. Ghosh, of conversation, cooperation is so important. We'll just take the last 2 minutes, my co-chair, Dr. Dalwai, for your minute of reflection and conclusion, and then I will take.
Thank you very much, Chair. After listening to two wonderful lectures, there's a little that can be said within a short period of time. I would like to leave you with two thoughts. Thought number one, in 1940s, 50s and 60s, and for India particularly in 60s, the partnership of Dr. Norman Borlaug and Dr. M.S. Swaminathan, who introduced the short duration dot varieties to get us more yield than what we were getting conventionally, was a reaction to the severe food deficiency in our country and across the world. Asia and Africa in particular were literally on fire, and there was no peace thanks to deficiency of food. So it was more a reaction. What we must understand is that there's a difference between reaction and response. Today, with at least adequate carbohydrate available to keep the body and souls together, we have the luxury of responding to the situation by examining the pros and cons and converting the compromised generative agriculture into a regenerative system. And that's what the two speakers have brought out. Thought number two, as E.F. Schumacher said, production challenge has not yet been addressed. Mankind lives under the illusion that production challenge has been sorted out. It's not. Today, we see the new challenge to production as two speakers have brought out. The folly lies in the meaningless approach to you considering wealth as an income. Agriculture depends upon natural resources that do not have boundaries in the artificial constructs of states and nations. Natural resources are an asset. They are a wealth of the society. If we do not know how to use wealth, then we use wealth as an income, and that's where we end up with these kind of problems. So we should know that regenerative agriculture depends upon sustainable, circular, and renewable form of approach to using the resources, whether it's water or soil or air, and then we are actually utilizing the income. So these are the two thoughts that I would leave you with, and thank you very much. And I take this opportunity before the chair thanks to thank the two great speakers, and you have really given us good insights for us to ponder over. Thank you very much.
I don't have to add much, but to say that when this centenary tribute was being planned, one of the things that the foundation and all of us who find inspiration in Professor Swaminathan wanted to do is to foster discussions and collaborations. Both our speakers have done that. You've pointed to potential technologies available, but you've pointed us also to the lack of investment in collective thinking. And I think as we go forward, we will see not just the connection to Professor Swaminathan's legacy of science for society, but I think his moral and ethical compass that he always provided to think about the poor and the most vulnerable, but also to think about how everybody can be part of the solution. So the questions from the floor about people's participation was key, and I hope together we will keep the questions that my co-chair kept in your mind alive, but also to think of how we are shaping the future of 2 billion children who are at the crossroads of some of the most extreme conditions in growing up, not in the homes, not in their communities, but affected by extreme poverty, conflict, and the risks that climate change provides. So together, may we continue this conversation, and to both you, Dr. Garrity, who have joined us from Kenya, and to you, Dr. Ghosh, thank you for a wonderful hour of listening. Thank you. Thank you.
Thank you very much. Now I request Dr. Ashok Dalwai to hand over the memento to Dr. Aram. And Dr. Aram, you can hand over those 2 mementos to speaker as well. Thank you very much.
Hello everyone. There are a couple of quick updates. The session on climate and health will be happening in Prithvi Hall. The session on multi-stakeholder forum will be happening in C1. Already School Corner and NAAS Yuva session is happening. School Corner is happening in C2 and NAAS Yuva session is happening in N1. We can break for tea right now, and we'll be starting the parallel sessions at 11 o'clock. So thank you so much.